Welcome back, my friend, to a new lesson in my channel on YouTube, Drilling and Workover. If you are not subscribed in the channel, please press to subscribe to get the updates videos daily. And if you are already subscribed, please click like when the video has finished. Yesterday, we have to talk about the pressures or the pressure engineering in the well control. We have taken about the hydrostatic pressure, about the formation pressure, about the also the dynamic pressures. Also, we have talked about the fracture pressure. And today we will take some questions which may come in the exam. So you are updated daily with the course and with its questions. Okay, so now we will go to the questions directly on the last part. Uh, this part is about the question. Wait a minute. Okay, okay. The first question is, what is the most common causes of the of abnormally high formation pressures worldwide? Here you have four answers and you just use one. You should choose one. Carbonate layers like limestone, like dolomite. No, it is not. It's not the main reason for abnormal. It may be no abnormal or may not be or maybe not normal and not abnormal. Abnormal. But most common limestone is depleted zones. Number two, depleted sand. No, also not also because depleted sand means that the pressure of the formation is less than the normal gradient. So it is not the right answer. Number three or number C, naturally fractured limestone, the same like before. So they are not the right answer. Number D, under compacted shale. This is right answer. No, why? Because under compacted shale, it has the shale has low permeability, and or its permeability it reaches to 0.001, for example, and you know the unconventional reservoirs like shale gases and blah blah. So the shales are with low permeability. So its water inside it is under the pressure. So there is no squeezing for this water inside it. So it is highly stressed and and there is high pressure inside it. So the best answer or the right answer is under compacted shale is the right answer. Question number two. A formation is overpressured by an Artesian effect. Artesian effect, by the way, we will talk in details about the causes of kicks, and one of the causes are the abnormal pressures in the zones. But here, the Artesian effect means that if you have a sea, like in Alexandria or in Marsa Matruh, it's the sea, and the land which is very low in the level or below the level of the sea level. So there is contact from inside from below between that sea and another formation and another formation below, so that this contact makes the sea act as a high pressure over the formation. So if there is contact between them, so to know the Artesian effect, there are two questions. The source of water is above the rig, or the another question, it may come the rig is in the land below the sea level. So which one is here? Okay, number A, a formation water source is at higher level than the rig floor. This is the right answer. Number B, the density, the difference between gas and formation. No, this is not. This is wrong answer. The formation is compacted from the overbended. No, also this is right. This is the wrong answer. The rig floor is higher than the formation. No, this is wrong. So the best answer is number A, which is a formation water source is at higher level than the rig floor. Okay. Number three, which one of the following values is generally accepted as a normal formation for pressure gradient. This is you must study by heart, okay? It must be studied already, and you know the number. So it's 0.465 psi per foot. So you have to know this number, and you know it well. What is meant by abnormal pressure? As I told you yesterday, abnormal pressure, which means that the normal gradient, this is the normal gradient, okay, and it is multiplied by the true vertical depth. So it gives you the pressure that it should be, which is the normal. But if it is more than that normal, which means that it is abnormal. If it is less than this pressure, so it is subnormal. So let's check now. What it means by abnormal pressure? Let's check that answer. The excess pressure due to the circulating mud at high rates. No, has no meaning. Number B, the excess pressure that needs to be applied to cause leak off. No, also this is not the right answer. A heavy weight mud used to give an overbalance. This is also not the right answer. But number D, the formation fluid pressure that exceeds the formation water hydrostatic pressure, which is the right answer. Or here the formation water hydrostatic pressure is the same like the normal gradient pressure. They are the same meaning. These are the same meaning. So the formation fluid pressure that exceeds the formation water hydrostatic pressure, this is the right answer, number D. Number 5, in what situations would formation pressure be called abnormal pressure or over pressures? This is the same question like before, but in another words. Let's check the answers. When excess pressure must be applied to cause leak off into a normally pressure formation. No, so it's wrong answer. When heavy density fluid is used to create large overbalance. This is also wrong answer. Number C, when the formation fluid pressure exceeds formation water hydrostatic pressure. This is the right answer as before. And last one is not for the circulating fluid. It is not the right answer. Number 6. When would you consider formation pore pressure to be abnormal? As I told you, abnormal when the gradient of the formation pressure is above 0.465. This is the right answer is number C. But try to check the other answers. When the rock formations contains fluid, has no meaning. When drilling with oil-based mud, has also no meaning. When the gradient of the formation pressure is below 0.433, this is also not the right answer. This is not the right answer. So the best answer or the right answer here is number C. Now the static and dynamic pressures. The static, which is the hydrostatic pressure, and the dynamic pressure while pumping or circulating pressure. So let's check. Which one of the following will affect bottom hole pressure, okay, while circulating at constant flow rate? By the way, tomorrow, inshallah, we will take the calculations. So it will be about the volumes, the strokes, and the pressures. So it's very important to know tomorrow to attend the lecture and see it and see the episode for tomorrow. Now, which one of the following will affect the bottom hole pressure? You should have two answers. Let's here take a note. Here two answers mean two right answer. If you have got one answer right and the other one is wrong, both will be wrong and you will lose the marks. But if it is two answers, it means two right answer. Both must be us. So when we talked yesterday about bottom hole pressure, the circulating, we have talked about the ECD. Okay, so we talked yesterday and try to check about the last episode. We talked about the annular pressure or annular pressure loss and the hydrostatic pressure. So the hydrostatic pressure means the mud density. So which is the following affect bottom hole is the mud density. This is the right answer. And annulus pressure loss, which also is right answer. But the pump pressure, no, it's pump pressure is affected by the frictions. It's affected mainly by frictions in the bit nozzles, in the drill collar, in the drill bit, in the annulus also, but it is not the main reason. Also, pressure loss through the bit nozzles is not the answer. So the best answers are A and B. Number two, the equivalent circulating density or ECD determine the actual bottom hole pressure while circulating. Yeah, which part of the system pressure losses contributes to the ECD? By the way, you know the pressure losses, with the pressure losses, it's determined by the pump pressure. So it can be the surface lines has part of the partial losses, which plus or minus 5%, and then the drill string or the drill pipes plus or minus 10%, and then the drill collars also because it has narrow ID, and then also the pit nozzle, which plus or minus 50% of the pressure is lost in the bit nozzle, and also the about 15 or plus or minus the rest in the annulus. So here are the total circulating. So once which one affected in the ECD? As I told you yesterday, when you hear ECD, you must make eye contact with the annular or annulus. This is annular or annulus. So the best answer here is number D, the pressure loss in the annulus. But the pressure loss in the surface is not, yeah, it is not the right. The pressure loss in the nozzles is not the right. The pressure loss in the drill string is not the right. And also in the open hole section only is not the right. So the best answer here is number D. Okay. The driller pumps a heavy slug. By the way, we will take the slug later, but it's here a common question. The heavy slug is bumped in the drill string after reaching to the TD and start to to pull out of hole with dry tubes or with dry drill pipes. So the people cannot so we cannot lose much more mud, and also the rig floor has no messy problems about the flowing and the blah and about these issues. So we bump heavy slug. Heavy slug is plus or minus 2 ppg over the mud, and it's about 25 barrels in the 5-inch drill pipes, plus or minus 25 barrels in the 5-inch drill pipes, or 15 barrels in the 3.5 drill pipes. But why we bump slug? We bump to waterfall in dry. Okay. Okay, let's see the question. The driller bumps a heavy slug and displaces it to the drill pipe with active bit fluid. What effect will this have on the fluid bits after disconnecting the top drive? Let's try to imagine with me. There is a U-tube happens between the drill string and the annulus. So once you pump the heavy slug, it's okay. The same volume, once you are bumping, the same volume come to the bed. So when you bump 20 barrels, the same 20 barrels while bumping are coming to the bed. So there is equal. But once you make disconnect of the of the top drive, there are the pressure in the annulus must be the same in the drill string. So U-tube occurs. But 20 barrels is much more in weight than the other mud. So its pressure, its volume, its level will become below. Its level in the drill string will become below, and you could pull out fall dry. But to become below, there is another volume must come to the bit. So the answer of the question here, once you disconnect the top drive, the total volume of the bit will increase. Okay, So the total volume will increase in the bit. Okay, this is the right answer, number B. During normal drilling operation, okay, 20 barrel of light fluid. Light fluid means that its density or mud weight is less than the normal drilling mud weight is pumped into the string, okay, followed by original mud with the light fluid inside the drill pipe, and take care of this word inside. The driller shuts down the pumps to monitor the well. What happens to the bottom hole pressure? As I told you, the bottom hole pressure, the pressure in the annulus must be the same in the drill string. So the bottom hole pressure is the same. Okay. So once the light mud is inside the drill string, the pH, the bottom hole pressure is the same because there is no change. There is no change in the annulus. So the annulus keeps the bottom hole pressure the same. So if he told you that the light mud or also heavy mud, if it is inside the drill string, there is no change in the bottom hole pressure. So here your eye contact must go to no change or are the same. So the first answer, the bottom hole pressure will increase. This is the wrong answer. Number B, the bottom hole pressure will remain the same. This is the right answer, number B. So this is the right answer. Bottom hole pressure will decrease. No, this is not the right answer. So the best answer is number B. Also, even I told you, even it is also not light. If it is also high mud, that is the same answer. Okay. Right. 4.5. Which factors will affect the bottom hole pressure while circulating? While circulating. Circulating means the dynamic pressure. So the ECD, so the losses. Okay. While circulating at constant flow rate. And also here choose two answers. As I told you, while circulating, you have the hydrostatic pressure and the annulus friction losses. So your eye must go to both of them. Number one, the annulus pressure losses is the right answer. Number two, drill string pressure loss. No, this is the wrong answer. Drilling fluid density means the hydrostatic pressure. Okay, so this is also the right answer. Number 4 and 5, they are not the right answers for the bit nozzles and the pump pressure. So the best answers here are number A and number C. Okay. Number 6. The bit level increases when the pumps are off, but the bit level stays constant. Okay, the bit level increases when the pump is off, but it stays constant when the pumps are running. This is what I told you yesterday. The ECD is affecting on the bottom hole, but once you stop pumping, the hydrostatic pressure is not enough to keep hole stable or to keep hole under control. So there is a problem. As I told you also, when you make connections, you have gases or connection gases on the shakers after one bottom up. So this means that you lost the ABL or annular pressure losses. So here, try to check the answers. Number A, the hydrostatic pressure is greater than the formation pressure. Oh, this is the wrong answer because if it is greater than this, it will be all the time there is no flow or there is no bit gain or there is no problem. Number B, annular pressure losses are creating an overbalance that prevents the well from flowing. This is the right answer because while circulating there is annular pressure. No circulating, nothing. It's just only hydrostatic pressure or ESD, equivalent static density. This is another issue. Number C, the pump pressure is greater than the hydrostatic pressure. No. Number 4, the pumps have failed. No, also this is not the right answer because he told you while circulating and there is no circulation. So the best answer here is number B. If light bill is pumped in the drill string and followed by 10 barrels original mud. Light bill. What can it lead to after disconnect the top drive, if the light bill doesn't come out from the nozzles? Doesn't come out from the nozzles, it is the same if he said it is inside the drill string. This is the same meaning. Okay? Okay, assume there is no float valve in the string for sure. Uh, the same is nothing will happen to the bottom hole pressure, as I told you that the annulus is the same, there is no change. Okay, so the best answer here is number C, nothing will happen. Number 8, heavy mud bill is circulated around a well. When will the bottom hole pressure first increase? As I told you, or if it is heavy mud weight, the bottom hole will increase, or if it is light mud weight, the bottom hole will decrease. This is the same answer. It's the same answer, okay? If it is heavy mud weight, heavy mud bill is circulating around the well. When will the bottom hole pressure first increase? Increase when it comes to the annulus. When it first comes to the annulus, first, just because the annulus became not homogeneous and the drill string is also not homogeneous. There is two mud weights, you know, the mud weight and the slug. Also there are in the annulus two mud weights. So the bottom hole pressure will increase once the once the bill started to come out of the nozzles. Not all the bills come out of the nozzles. This is wrong answer because it will change. So the best answer here, we will check it. Number A, as soon as bumping the bill into the drill string starts. This is not right. Okay, there is drill string, so this is no problem. Once the entire bill is in the annulus, means the entire يعني all, means all the bill, which is not the right answer because I told you once it comes to the annulus, this is the right answer. Once the entire bill is bumped into the drill string and it's about to exit, it's about to exit. This is not the answer. But once it comes out of the bit, so once the bill starts to be displaced into the annulus, this is the right answer. So the right answer here is number D. Last question. What is the reason of having a trip margin? Yesterday we have taken, I have told you about the reasons of to make a trip margin, and I told you that the mud weight must be between there is gradient or there is drilling window between the formation gradient and fracture gradient. So the mud weight must be in between. But I told you that we have to take plus or minus 200 psi over balance. Why we take 200 over balance? It is called a trip margin. Because if you pull out of hole, you may make some swabbing and gases come from the formation and it may escalate to the kick or pull out, even pull out. So the trip margin here is to avoid the swabbing problems. Okay. Number A, to allow for a level drop in the well if there are losses. No, this is not the right answer. Number B, to compensate for possible swabbing effects during pull out of the hole. This is the right answer. To create a safety margin in case of trip tank readings are not accurate or are inaccurate. This has no meaning at all. Number D, to create an overbalance when back on bottom drilling. No, this is not also the right answer, but the best answer here is to compensate for possible swabbing effect during blowout of hole. Today we have finished the questions of the pressure engineering. Inshallah, tomorrow we will take another issue which will be about the calculations. It will be about the capacity, the volume, the number of strokes, open end and open end, the metal displacement, the closed end displacement, and a lot of calculations. So keep tuned for today because this is one of the most important episodes in this course. Thank you very much, and I hope everything this video admires you admire this video. And if this video appeals to you, please click like, subscribe, and share video if you can. This channel is your channel, and thank you for everything. Thank you.